Alright, which color should we use? Should we use, well, I guess we shouldn't use blue. Guess we shouldn't use blue. Probably shouldn't use blue. Maybe not blue. I think we'll use black. I think black's a good choice. Sup gamers, I'm back. Welcome back to Calculus. It's your boy. Now, what we're going to be doing here today is we're going to be doing part C, which wants us to find the convergency of part B. Now, part B, as you can see, I wrote here. So what we got to do to find the convergency of part B for part C is we got to apply the ratio test. Now, you spell ratio R-A-T-I, and the A-T-I are all lowercase, but then you make the O capital again, so you can put a smiley face in it. Then you write test. And what this says is that as the limit of n approaches infinity, a, n plus 1, is over a of n, and it's going to show us something. It's going to equal L. And I'm going to tell you what L equals later, but you already know that. So what we're going to do is we're going to plug this boy into here. And what we have to do in order to get a n plus 1 is we have to plug n plus 1 into n. So what we're going to do is we're going to do just that. X minus 1, 2, n plus 1, parenthesis, over n plus 1 factorial. And that turns into x minus 1 to n plus 2, n plus 2 factorial. And if you didn't get that, you're a dumb little baby. All right, let's keep going. Let's keep going. So what we're going to do is we're going to plug in our functions for this. So we're going to get lim n approaches infinity over, I'm going to write this real small because there was a lot of numbers, and I've done other takes of this, and I ran out of space, over, n parenthesis, over the original function, 2n over n plus 1. Now that laugh you just heard, that was my mother. So we're going to keep going. We're going to simplify this. We're going to put the things where they belong. And what I mean by that is we're going to flip over one function at the same time we move them around, because I'm incredibly lazy and I don't want to do a lot of work. So what we have here is we've flipped over the bottom function, flipped it over so we can multiply instead, and now it's written out in a way where we can cancel some stuff out. So lim n approaches infinity. So sick of writing that out, by the way. X minus 1, 2n plus 2 over x minus 1, 2n cancels out to x minus 1, 2, 2 squared, one might even say. This mess is a bit more complicated. The factorials, what we're going to do is we're going to write it out long form. So 1 times 2 times 3, dot, 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 because I'm lazy, to n plus 1, because that's the last term, over 1, 2, 3, dot, 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 n plus 1, n plus 2. And if you didn't know why we did that, it's because you forgot. Because what we're doing is n plus 2 is 1 more than n plus 1. So the term is going to be 1 more. And now we're going to write the n parenthesis, and we're going to fix the first parenthesis. And we're just going to cancel all this out. We're going to cancel all that out. We're going to cancel out the n plus 1 and the n plus 1. Because that's how that works. That's just division. That's just division. All right, and so now what we have here is an absolute value, and then we have the limit as n approaches infinity of the absolute value of x minus 1 squared over n plus 2. And now we apply the limit. You know how to do this part. I'm going to squat down a little bit so I can write better. Oh, I guess if I'm applying the limit, I don't really need to write that. So we have x minus 1 squared times 1 over infinity plus 2, or x minus 1 squared times 0, which equals 0. Now, we're going to go back to L, because that doesn't really tell us much. We got to go back to the L. We're taking L. We're taking an L. If L is greater than 1, it means, hold on, I wrote it on my paper, it means the series diverges. If L is less than 1, it means it converges, and if L equals 1, it means you have to do another test. Now, at home, does 0 equal 1? Is it less than 1, or is it greater than 1? And I'm going to give you a minute to think about it, because I know some of you are not thinking with your brains. You're thinking with your elbows or something. That's right. L, which is 0, is less than 1. So this converges from negative infinity to infinity because we didn't plug in any x values for x. We just left it as an x and it got rid of itself normally. Thank you for your time. I'll be here all week.